Welcome back to the Mapscaping podcast. My name is Daniel and this is a podcast for the geospatial community. Today on the show I'm talking with Kyle Barron. Kyle is a cloud engineer at Development Seed, and today we're talking about GeoParquet. So this is a cloud native geospatial format, and if you're familiar with COGs, so cloud optimized geotiffs, think of it as the vector version of that. And if all of this cloud native geospatial stuff is feeling a little bit overwhelming, please check out the show notes today. We've actually covered this in a fair bit of detail, and you'll find episodes specifically around COGs and specifically focused on cloud native. And I think this is an incredibly important topic to get your head around if you're working in the geospatial industry. You might have already heard things like range requests and chunks and streaming data. Or maybe someone's mentioned the fact that you don't need a server. There's no GeoServer map server required to serve this data. And you might be wondering how all of this stuff fits together. Again, please check out the show notes today. There'll be links in there to a bunch of different episodes that'll help you understand this. So normally about this time in the introduction, I mention the sponsor and say thank you very much for your support. Today there is no sponsor. So I want to tell you briefly about a new project that I'm working on. It's called Quick Map Tools. You can find it at quickmaptools.com. And as the name suggests, it's going to be quick map tools that run in the browser. So we started off with a bunch of conversion tools and we'll keep building on top of this. Keep an eye out on it. There'll be a link to it in the show notes if you're interested in checking out. And I'd also really appreciate any feedback. So if you do take the time to use quickmaptools.com, let me know how it goes. Let me know what we can improve on and how we can make it better. Really appreciate it. Thank you. Okay. Here is Kyle Barron, cloud engineer at Development Seed, to help us understand what GeoParquet is. Hey Kyle, welcome to the podcast. Let's try this introduction again. The first time I tried this, I made a slight mistake. You were polite enough to correct me. So, you are a cloud engineer at Development Seed, not GeoSeed, which is what I said at the start, Development Seed. And today on the podcast, I really want to hear more about GeoParquet, and I'm hoping you can help me with that. But first, let's start with a brief introduction. Who are you? What is cloud engineering?
Thanks for having me on the podcast. Yeah, I'm a cloud engineer at Development Seed. It's a bit of a catch-all title. I don't deploy as much services to the cloud as some other people with the cloud engineer title. But I work with a lot of open source projects at Development Seed to help our clients. We're a geospatial services firm that does work with NASA and other impact-focused clients to help their scientists do really interesting work on large geospatial data sets. And so some of the work that I do is to enable adoption of cloud native geospatial file formats and interoperability with open source projects, and to help scientists be able to do more processing on their data using these new data formats.
Brilliant segue. Cloud native, you mentioned that there, which is going to be great because we're going to be talking about GeoParquet in just a second. I just want to stay with your title for a second, cloud engineering. There's no geo in that title, but you work for a geospatial company. Does that mean that you do a little bit of geo and a lot of sort of cloud engineering, or how does that sort of fit together?
I think that at Development Seed, we think that the cloud is really the future of working with large data sets. In older ways of working, you might take some satellite imagery scene or some large vector file, download that to a local computer, and then do some operations on that. Now that we have much larger file sizes, it's a lot easier to use resources that are hosted on cloud providers like Amazon, Google Cloud, or Azure Cloud, to name a few, that lets people scale up their workloads a lot better than they could if they had to go out and buy their own computer. And so some of these tools like GeoParquet allow us to work with these larger file formats where maybe you could prototype your processes with small data, but then use some of those same tools on very large machines that you just use for the process that you need, that you're able to rent for a short time from a large provider. And so I do a lot of geospatial specific work, but it relates to our belief that the cloud is becoming more and more important in how people are using geospatial data today.
Okay, that makes a lot of sense. Well, I think we should just jump into it. GeoParquet, what is it? We've mentioned cloud native quite a few times, and you've just sort of focused on the importance of the cloud. So Let's help the listeners understand this. Let's tie things together for them. What is GeoParquet?
GeoParquet is a new file format for storing geospatial vector data that builds upon the existing success of an existing file format called Parquet. And so Parquet, in the non-spatial sense, has been around for about a decade, steadily gaining steam. It is used to store tabular data, where if you think of something like Excel, where you have a table, which is a collection of columns, and each of those columns has some data. Some of those columns might be numeric. Some of those columns might hold text. And then extending that to a geospatial context, you might have a column of geospatial features where each geometry is associated with one or more properties. And we can model that in this tabular form by describing this geometry column associated with these attributes that Parquet can already handle. And so GeoParquet is not a new file format in a sense. It is using this Parquet file format and describing a standardization for how to store geospatial metadata in this existing file format. If anybody is familiar with raster data and cloud optimized geotiffs, it's very similar, where cloud optimized geotiffs and geotiffs were both built on the success of the TIFF file format, which enables you to use a lot of the investment that has occurred outside the geospatial industry for some of these existing file formats like Parquet and TIFF to use now with geospatial data.
Okay, so the geo industry, or people like yourself that are working on this problem, you're standing on the shoulders of giants. So Parquet is a cloud native format in itself, and you're showing up and building this geo extension almost to it.
Exactly. Several of the best characteristics of GeoParquet we really get for free by building on top of this existing Parquet file format. That Parquet indeed is itself a cloud native file format. And as long as we can organize our geospatial data effectively, then we can get some of these existing benefits for geospatial data as well.
So I think a good way of breaking down this conversation for people would be to talk about this in three parts. Let me just run this by you. I'd like to talk about the spatial indexing, which for me sounds a lot like this metadata that you're talking about, the geo extension, if you will, to Parquet. And then I'd like to talk about the compression, why this is interesting, why it's important. And in a previous conversation, you mentioned something called geo arrow, and I'd like to try and relate that to Parquet and help people understand how those things might work together. Does that sound okay to you?
Yeah, that sounds like a great overview.
Cool. So let's start with the spatial indexing, because again, we've been talking about metadata, that this geo bit that you're building on top of the Parquet file as we know it today. And you mentioned COGs earlier, so cloud optimized geotiffs. They've done this successfully over there, at least in my mind. It's a massive success. Why is this difficult with GeoParquet? If we've already done it with COGs, why can we just import that same knowledge over to vector data, to Parquet?
There's a difference between indexing raster data and indexing vector data. And it's really important to understand how these are different. Indexing raster data can be relatively easy because the pixels are small compared to the extent of the data set, and the pixels are regularly gridded. So you know that all the pixels are in a row in a specific ordering. Vector data is a lot harder because the data can be irregular. So for example, if you have long rivers or long flight paths that might stretch over half the world, it's really hard to organize those flight paths, those geometries, in a way where all of the nearby data is sorted close to each other in the data set. Because you might have some geometries that intersect much of the rest of the data set. And that's really hard to work with compared to raster data.
What about vector tiles, for example?
Vector tiles are a really great technology for viewing data, but it makes it harder to work with some analytical data compared to visualization data. And so, for example, with vector tiles, you clip geometries to a tiling grid. And that means that if you look at one geometry in one tile, you don't know the full extent of that geometry. and how many other tiles that are bordering the current tile you might have to fetch to get the full extent of your geometry. So, for example, if you looked at a coastline near New York City, the full extent of that coastline includes many, many more tiles, and it's hard to connect which other tiles you might need to load to reconstruct the full original geometry.
Okay, so I realized that was a really blunt question, but what I wanted to get out of that was that there's a difference here. When we're talking about visualizing data, vector tiles, that might be a great approach, but when we're talking about analyzing data, it's not going to work for the reasons that you just mentioned there. So if you're sitting there wondering, that was the world's dumbest question and the world's bluntest question, that's what I was hoping to get out of it. But there are examples of people solving this hard problem. When I think about flat GeoBuff, for example, shapefile, GeoPackage, what is different about their approach? Like, why can't we use their approach in GeoParquet?
You bring up a good point that other file formats before GeoParquet have implemented spatial indexing as well. And so I think looking at flat GeoBuff, which is a really good file format as well for its own use cases, and how flat GeoBuff spatial index compares to GeoParquet is really illustrative. Flat GeoBuff indexes every geometry individually. And so this has the downsides of making the spatial index very large. If you have many geometries, the spatial index can become a significant percentage of the total file size. And it also prevents any effective compression because the spatial index has to be able to reference every individual geometry individually. GeoParquet instead implements this kind of grouping, kind of like what Cloud Optimized GeoTIFF does, where it indexes a collection of geometries at a time instead of just one. This enables it to scale more effectively to larger data sizes. It also means that each of those groups can be compressed as one, so that if you're fetching one of those groups, you get the compression from that group, and that group is the unit that you are inserting into the spatial index.
Okay, that makes a lot of sense. How do you decide how to group that data? And is that something that GeoParquet says that you have to group data like this?
GeoParquet enforces a grouping. It enforces that there is this concept of groups, but users can choose how many rows they want in each group. And they can also choose the sorting of data within their groups. And so the upcoming GeoParquet 1.1 specification defines a way to store metadata so that the spatial extent of each group is known, but it doesn't prescribe a specific way for users to do that sorting. And so it enables potential innovation in the future when potentially there's different sorting algorithms that might be better or worse for different types of data. And so we're defining the specification in a minimal sense, but also that lets people figure out the best tool for their own data.
Is that going to make it harder to maybe to read and to write this stuff that then perhaps like flat GeoBuff that just says, this is what it looks like and it always looks like this? Because my guess is that with this flexibility that you're talking about, it becomes more complicated for reading and writing this format.
On the reading side, there's actually no extra complexity. The reading side works the same way, however the data has been sorted. The reading side is able to see from just the metadata that you fetch at the beginning when you're reading the file. From just that metadata, you can see the bounding box of each of the groups in the file. It can implement these spatial queries the same way, no matter how the data was saved. It does mean on the writing side that there is more research to be done for the best ways to do some of this sorting. We can use some of these existing techniques, like Hilbert curves is how flat GeoBuff does its spatial indexing. And we can implement some of those techniques in GeoParquet when writing, but it also provides a lot of flexibility. For example, the Overture dataset, which is an addition to OpenStreetMap by some large corporations, has a large building dataset, and they use quad keys to organize their GeoParquet data, but that still works with the GeoParquet specification.
I think it'd be really helpful for the listeners and probably also for me to put this in a use case. You mentioned Overture, the Overture Foundation before. These are massive data sets. I've actually published an episode with them before, and I'll link to that in the show notes. But let's have this sort of, let's use this data set as a use case. Tell me why flat GeoBuff is a bad choice to save in terms of Overture data, and tell me why GeoParquet is a good choice. And if we make a little bit of if we do a bit of comparing and contrasting, I think this might help people understand it better.
Yeah, that sounds great. For example, let's look at the Overture data set. Overture is a really large data set that builds on top of OpenStreetMap. For example, they have a buildings layer that takes some data from OpenStreetMap but combines other data from AI-generated sources, where this single layer has 2.3 billion rows spanning the entire globe. And so a data set this large is hundreds of gigabytes. And if they tried to save that data in flat GeoBuff, it would be really, really tough to index all of that in a single file that allows them to scale, because it would take a lot of time to load the spatial index in the flat GeoBuff file and to find the pieces of data that they need to load to satisfy their query.
And what would it look like in GeoParquet?
In GeoParquet, currently Overture saves all of their data in GeoParquet. And this means that they're able to sort their data. So I'm working with some members from the Overture team to build a website to access Overture data. And this website is able to read Parquet directly without a server involved. For example, in about 15 seconds, passing in a bounding box around the city of Boston, we were able to read straight from the cloud storage to the web browser in about 15 seconds. And so that took the metadata from the files on cloud storage. It looked inside the metadata to see which regions of data were stored in different files and in different locations within the files, and then figured out which portions of those files to fetch into the user's browser in this application.
Well, so that's a lot of data, and it sounds quick. I just want to point out that it sounds like you what you're talking about is like multiple files. So not only is partitioning happening within the file itself, this spatial indexing that we've been talking about, but it sounds like you're also partitioning the data into different files. And my guess is each file is for a different region. Is that correct?
Exactly. It's very common in GeoParquet to have some partitioning across multiple files, but it's also possible to have more partitioning inside a single file. And you can mix and match which levels you do this partitioning at. And a lot of systems out there that read and write GeoParquet data know how to use these multi-file collections of data. So for example, I believe Overture is using the Sedona program to create these large data sets. And it's easier to write these collections of files sometimes than to write a single file, because that means that multiple machines can write data independently to each of these files, which makes it faster to work with some of these really large data sizes.
Well, it's when you start diving into the world of spatial indexing, it's not easy, is it? And I guess a lot of this depends on the data itself in terms of how it's broken up. But it always surprises me how complicated it is to partition data, these large data sets. What makes sense, and I guess ultimately it depends on the use case as well. But I think you mentioned 2 to 3 billion rows before, and that's partitioned over in different files. And part of the reason why you're doing this, it sounds like anyway, because it's easier for multiple machines to do this as opposed to like having one machine write to one file, and then the partitioning within that file as well needs to be thought about. It sounds like a science in itself, to be honest.
Yeah, absolutely. It's a very difficult problem to handle data this big and to handle efficient spatial partitioning. And this is part of the reason why in the specification, we are endeavoring to define a simple way to read this data, but we don't want to close off some of this innovation for what is the best way to store data and what is the best way to implement this partitioning. We want to find this middle ground where there's a lot of innovation that people can do in the future. And so the GeoParquet 1.1 specification includes this way for however the data has been saved, readers know how to infer this spatial partitioning.
And just to help, again, to help solidify this in people's minds, is GeoParquet a good choice for people that for transactional use cases? If I'm expecting to return one or very few items from a query, is that where I should use GeoParquet? Or is it more for this? It sounds more like it's for this massive data sets where I want to do analysis over a huge amount of data.
You're right that GeoParquet is not a silver bullet. And while it's really good for some analytical use cases, it isn't designed for some of these use cases, these transactional use cases where you want to just get a single record or update or modify some of your data. There is work being done to improve being able to update Parquet data files, but in general, it's easier to use existing tools like Postgres and PostGIS than GeoParquet for some of these use cases.
Okay. Whew, we did it. We got through the spatial indexing side of things.
Yeah.
Well done. Really, really interesting.
Like, it's really tough and kind of stressful to do this at a approachable level.
Yeah, you're doing a great job. At least I'm following along. I really hope that the listeners at home are also following along. Yeah. But if they're like me, they'll probably go back and listen to this a couple of times. At least I had to do this with our pre-interview. Okay, big breath, and let's move on to compression. Are you ready?
Okay, yeah.
Compression. Why is this an interesting thing with Parquet? And why will this help us when we think about GeoParquet? What is great about Parquet and compression? And maybe you can compare it to something like, I don't know, a shapefile or GeoJSON.
So GeoParquet includes really efficient compression, which makes it a lot faster to move data between systems over a network. So often you have some data on the internet that you want to share with a lot of people. And if your data is a lot larger in file size, it means that when people do download that file, it takes a lot longer to access that data. And so there's use cases, even when you don't care about the spatial partitioning of GeoParquet, where GeoParquet is the best file format because it's the most compact to download. So for example, I work on this geospatial data visualization library in Python called Lawnboard, which connects Python to interactive browser-based map visualizations in the Jupyter programming environment. And as part of this, it has to move large quantities of geospatial data from Python to JavaScript for visualization. But in some cases, a Python session is running on the cloud instead of on a local machine. And that means that this movement is actually downloading data over the network from a remote computer to the browser. And here, a common example I look at is an example with 3 million points, where that data in GeoJSON was about 500 megabytes uncompressed, whereas GeoParquet is only about 30 to 40 megabytes for that same data. And so that means that we can move data so much faster between each of these systems.
So that sounds really impressive. I got to admit though, like JSON, you picked maybe the world's most uncompressed format, but I appreciate the comparison. And I just want to highlight here that we're not just talking about range requests anymore, are we? We're not just talking about asking for pieces of data, which for me anyway is kind of the magic of these cloud native formats. We don't have to start at the start and end at the end. I just want this middle piece of this data and get it and access it like that and consume it and like that. But you're talking about downloading entire files now.
Yeah, this compression aspect both works with spatial partitioning. So if you only need a small portion of the file, or if you only need a few columns of the file, you can take advantage of this compression. But also, if you wanted the entire file, you still get these advantages of compression. And so part of this is because Parquet is a columnar file format, which means that under the hood, all of the data in a single column is saved next to each other. And it means that the compression, which uses the fact that similar data can be saved more efficiently when it's compressed, the data tends to be more similar within a single column than across a row. And so this is why GeoParquet tends to have much smaller file sizes than FlatGeoBuff. Even when FlatGeoBuff is compressed, GeoParquet tends to still be an order of 2. GeoParquet tends to be about half the size of FlatGeoBuff when compressed.
So, but previously we were talking about like saving GeoParquet. When we were talking about partition it, we were talking about grouping it, like saving it in chunks. Do we still get the benefits of this compression, even though we're possibly downloading much larger areas, many more rows than what we're actually interested in consuming?
Yeah, there's a trade-off here between how much data you actually care about and how much data you have to download. There's this internal chunking in Parquet, and so you don't have to download the entire file to access a single chunk. But if all that you care about is a single row, that is where the GeoParquet's compression is maybe outweighed by the fact that you didn't actually want a lot of data. You only wanted a single row. And so that's where some of these analytical use cases like grouping or group bys or joins, if you wanted to join 2 different data sets together, where you really do have to look at all of the data to figure out this join between 2 different spatial data sets.
Okay, so I'm convinced GeoParquet is the next big thing. But let's try and join this to something called GeoArrow. This could be a little bit tricky. But yeah, so can you walk us through this? Maybe we could start with what is Arrow, what is GeoArrow, and how does it relate to Parquet?
Yeah, the third reason why I'm really excited about GeoParquet is because it has a really symbiotic relationship with this other technology called Arrow and a geospatial counterpart called GeoArrow. GeoParquet is a file format. And so when you read a file format, you have to read it into something. And so Arrow is this technology that most Parquet implementations read and write data from Parquet into Arrow and write from Arrow into Parquet. The strength of Arrow is really that it allows programs to efficiently share data at a binary level instead of a text level. And so I think it's instructive to look at an example here. Historically, say you're a Python data scientist and you have data in GeoPandas and you want to read and write with GDAL for geospatial file formats. Historically, GeoPandas had no way to share data with GDAL at a binary level. And so the way that it connected to GDAL was that GeoPandas would create a GeoJSON feature for each row and pass each of those rows to GDAL. This is really inefficient because GeoPandas at its core has this data in a binary format, and then it has to convert it to a text format to pass it to GDAL to pass it back into a binary representation in GDAL. In GDAL 3.6 and later, GDAL added support for reading and then also writing data from all of its drivers into this arrow format. This means that now, with some of this latest changes into GeoPandas, you're able to move data as binary from GeoPandas to GDAL directly. And so for some reading benchmarks, reading GeoParquet to GeoPandas via GDAL became 33 times faster. And reading FlatGeoBuff and GeoPackage became 23 times faster from going from GDAL into GeoPandas. And this is all minimizing these data transformations by agreeing on this binary format that GDAL and GeoPandas can share.
Wow, that was a great explanation. I really appreciate this. They sound like they have a symbiotic relationship, these two, GeoArrow and GeoParquet.
Yeah. So the Venn diagrams between GeoArrow and GeoParquet aren't perfect, but they overlap quite a bit. This means that like these examples with flat GeoBuff and GeoPackage, even outside of GeoParquet, GeoArrow has potential to speed up a lot of operations. But the fastest way to use data will still be with GeoParquet. The GeoParquet is the fastest way to read data to GeoPandas, for example, in Python. And it's because these formats were really designed to work together.
We've covered a lot of ground so far, so let me try and summarize things a little bit, and then we'll move off and talk about what the future looks like. So, GeoParquet. For me, it sounds like Parquet was already been around. People have spent a lot. People have invested a ton of resources in building this standard, which works really, really well. And now the geospatial world has showed up. We could use this too. We're adding this extension to it. We're calling it GeoParquet. And for me, this extension is the metadata. It's the way of describing how we created these partitions within the data itself, these chunks, the grouping of data. And it doesn't sound like the format says, hey, you have to do it like this. It says you can do it however you want, but you have to describe it like this. So when the reader shows up to read the file, it says, hey, oh, look, the description is great. I understand that, and I can read the file. Now, it doesn't sound like it's the best data format if I'm looking for a transactional relationship, if I'm just taking very few items out, but if I'm reading like a lot of items, a lot of information, if I'm moving a lot of information around, if I wanted to jump around in a file format, so these range requests, it sounds like a good idea. The compression sounds amazing. I think you talked about because it's a columnar format. And what this compression means is that even though we're requesting these large blocks out of GeoParquet in a data analysis situation, we might be throwing away some data, but the compression is so good that it doesn't really make a difference. It also means we can download the entire file easily and effectively. And then you describe the relationship between GeoParquet and GeoArrow and how they're kind of supporting each other and making reading and writing from file formats, significantly faster. Whew, how'd I do?
Yeah, it's a lot of content, but yeah, that's a really good overview of the situation.
I should be a podcast host. I think I'd be good at that.
Yeah, that would be great. One thing I would add is that the spatial partitioning of GeoParquet is really new, and it has to be defined in the specification before it can be widely implemented. And so we are just about to release this GeoParquet 1.1 specification to describe how implementations should include their metadata. And I think over time, there will be more libraries that implement this specification and handle this process of saving data in this partitioned manner so that the user doesn't have to actually think about that.
Yeah, I think that would be a humongous step forward, but I can also appreciate why it's not the easiest thing to do. After having worked on this for a while, are you more or less excited about a future with GeoParquet?
I'm still really excited about GeoParquet. I've been excited about Parquet since 2018, actually, and joined some initial discussions about GeoParquet in 2020 when it was being discussed as part of the GeoPandas project. And I'm really excited about a future where some data providers can share large data sets without servers. I'm excited about being more interoperable, both across a network in the GeoParquet sense and across programs on a single machine in the GeoArrow sense. And I think that there's a lot of innovation to come where you can decouple the problem of how do you store large geospatial data efficiently, and how do you represent that in memory really efficiently, where those respectively are GeoParquet and GeoArrow, and let programs focus on, okay, what's the best way to operate on this data? What's the best way to implement something like a spatial join? What's the best way to visualize large data? When we all agree for this use case, for this analytical use case on this file format. That, keep in mind, I've been using Python examples, but in R, there's also a big community working on integrating these GeoParquet and GeoArrow aspects. It's integrated into GDAL. That means it's also integrated into QGIS. And so I think there's a lot of potential for fast geospatial data science across a lot of tools in the future.
What bits of this, when we think about people implementing the use of GeoParquet in their data science, so again, where we're talking about large volumes of data and we're doing analysis across massive data sets, What bits do you think people are going to move away from transactional databases, from SQL databases?
I would keep in mind that SQL databases can be used for multiple applications. And so if you're joining large tables, that is very common to do in SQL, but is not the type of task that is most efficient for some transactional databases like Postgres compared to some other newer so-called analytical databases like DuckDB, which also has a spatial extension called DuckDB Spatial. And so the way of interacting with the system, this SQL query language, is not the determining factor for how efficient you can work with data.
Are there any competitors to GeoParquet out there in the world? Like file formats that are trying to do the same thing or very similar?
I think that this is pretty new for geospatial data to really focus on these large corpuses of data. It's also really hard to bootstrap an ecosystem of working with these file formats, where a question, if you're creating a new data format, is do you create something completely new just for geospatial? Or do you take some existing file format outside of geospatial and add geospatial capabilities into that? And there are pros and cons to each approach. Flat GeoBuff took something relatively bespoke just for geospatial and added lots of custom implementations to different languages, to GDAL, and so on. It's really a lot of work to take a format and implement support for that format in lots of different programming languages. That GeoParquet is one of the first formats that has really focused on this large data use case. I think we might see another data format that improves on Parquet in some ways in a few years. But for the time being, Parquet is really groundbreaking in its application.
Is this the end of GeoServer, of MapServer, of Postgres SQL?
I think that GeoParquet has some real strengths, but that it's not a silver bullet, and that if people are using some existing applications that work really well for their use case, it doesn't make sense if those are working well for people to change. I think GeoParquet is really focused on supporting these use cases that haven't been as well supported up until now, with these large data sets, this cloud native architecture with this large data that complements a lot of existing tools instead of replaces them.
I think it's really interesting because I can see it from the data provider's point of view, Oh, you're telling me I don't have to have that extra burden of running a server? Great, I could just create these files and put them there and people can access them. That sounds awesome. It sounds significantly cheaper as well. Like granted that there might be a lot of work in, changing your architecture and creating these files. I don't have the same insight into that as what you do, but I can see it from that perspective. And from the user's perspective, the idea that you can just show up and get the thing that you want quickly without having to, jump through too many hoops, that also sounds great.
Yeah, I think that data providers definitely see this as a pro. Looking at Overture, where their buildings data set is massive. And it's not the only layer of data that they have. They have other data for transportation data and so on. It simplifies their storing of data quite a lot because they don't need to have servers or databases maintaining this data. But it does mean that some users have to learn some new tools for working with this data. Ideally, the friction here can be reduced as much as possible by integrating GeoParquet support into GDAL and by having some helper tools, like there's a new Overture command line interface and Python library to work with this data that abstracts for the user the process of actually working with those Parquet files. But I think that unlocking certain use cases that weren't well supported previously, that it's worth this moving forward and working on new tools.
Kyle, I think this is probably a really great spot to round up the episode and say thank you very much. I really appreciate your time. You've done an absolutely brilliant job of walking us through what is a a complicated subject, and I really appreciate it. Thank you so much. Where can people go if they want to reach out to you, or follow along with the work that you're doing? Maybe learn more about the project that you're working on at the moment.
Thanks for having me on. I do want to express that it's not just me working on GeoParquet. There's a large number of collaborators that are also working on the project and implementing support into a lot of different tools. You can reach me on Twitter or X at Kyle Barron 2. I'm also on LinkedIn and Mastodon, and on GitHub at Kyle Barron, which also has my email address and website linked as well.
And if people want to try out, is it longboard or lawnboard?
I get lots of questions about this, and maybe the name was not the perfect choice. It's actually a pun on the name DeckGL for this JavaScript library that I'm using under the hood for rendering, where the part of a skateboard that you ride on is called the deck. And so what's a geospatial skateboard? A longboard. So yeah, this Python library is called Lawnboard. You can get to the documentation at ds.io/LONBOARD.
Cool. I'll find links to those things and put them all in the show notes. Thank you again for your time. Really appreciate it.
Yeah, thanks again.
Really hope you enjoyed that episode with Kyle Barron. There'll be links to where you can reach out to him, connect with him in the show notes of this episode. Also, a bunch of other links to topics that are related to cloud optimized geotiffs, for example, and to this overarching idea of cloud native geospatial. It's really worth understanding this. Also, as I mentioned in the introduction, I'm working on a new project. It's called Quick Map Tools. And by the name, you can probably guess what it's about. You'll find it at quickmaptools.com. Please go along and check it out. Any and all feedback would be greatly appreciated. Thank you very much for your time. We'll talk again soon. Bye.